Hello everyone, welcome. Today we are going to talk about TensorFlow. So let me go get my slides for you and share my screen. So TensorFlow is a really important software that's involved with machine learning, and it's typically considered to be the state-of-the-art way to do it. So it's very useful if you're interested in doing machine learning that you get up and started with working with TensorFlow. Now there's a variety of ways you can work with it. You can work with it on your own laptop by installing it, and you can also work with it online. So today we will hear a little bit about how TensorFlow works, and also we will talk about how you can work with it online if you want to just get up and started with it, which is probably the fastest thing to do. Or you can, if you're more serious about it, you can work with it on your laptop. We also have it available on our high performance computing cluster. So if you do get involved in it in a serious way and need that high throughput computing, it is possible to do that here at West. So with that, then let us get started. So machine learning, artificial intelligence, these things are all around us every day. We see this in Google, Amazon, Uber, YouTube, and so many more applications that we use on a daily basis these days. Because of this, we need to have some kind of a learning algorithm behind it, and Google's TensorFlow is one of those algorithms that is oftentimes used in order to power many of these powerful machine learning softwares that we use every day. So what exactly is artificial intelligence? It's a branch of computer science it's the study of intelligent agents, which is any device that perceives its environment and takes actions to maximize the chance of successfully achieving its goals, where the goals are something the user defines. And that's going to deal with how computers learn or how to do tasks typically associated with human learning. That's why we call it artificial intelligence. So we've been having some discussions earlier in this session about an overview of machine learning, but just to bring everybody up to speed, the basic idea here is we would collect some data, generate some hypothesis about what's happening, then we would use some model. And the idea here is that there are many different kinds of models that could be used. We talked about hidden Markov models, we talked about Markov state models, and some others, some vector machines, some trees, and those sorts of things. So today we're going to really be focusing on the neural networks, which is how TensorFlow is working. So we would be selecting that model here. So this idea with the film strip here is you could pull in any one of the particular AI learning tools that you wanted to use. So today's will be the neural nets. And then once we have our model set up, then we can iteratively refine that model to reflect data that we have available, or perhaps based on the output that we see, we may wish to refine that model. And so we would iterate through this and continue to improve our model and get better and better results. It's important to keep in mind this idea of having the training set, the validation, and the test set. So what these sets are for is you need to get the parameters of the model in the first place. So when we're going to think about a neural network, we'll need to provide some kind of a data set. Today we'll focus on a data set regarding some housing situations in the state of California. And so we will know what information we're trying to get out of this, and we'll just provide the neural network with all the possible information that it could use. And it's going to learn the parameters of the neural network. In order to validate our set, what we want to do is we want to have a separate set of data where we more or less know what the answer is, but that answer is not known to the machine that we made. And so if we have a particular prediction that we want to make, the validation set, we already know what that prediction is. And so we will see if the model has been appropriately trained, and if it is unable to extrapolate to the validation set, that would suggest that we've probably overtrained on the input data. Then once we've used the validation set to our satisfaction, that is, the model is able to predict answers where we know what the output should be, we can then apply our model to a test set with confidence. Some of the challenges of machine learning, which definitely carry over to neural networks, are insufficient quantity of training data, non-representative training data, poor quality of the data, overfitting of the data, and underfitting of the data. So TensorFlow is going to use neural networks for deep learning, so I thought it would be useful for us to take a moment to take a look at how neural networks work. So here we have a deep neural network, and which is the typical kind. So what this is referring to is the layers. So let's just take a look at this diagram here to understand what this is. So here is some input, right? So you're going to have some data, and that will go in at the input interface, which is these nodes here, which are representing the point of entry of the data. Then inside the model itself is going to learn a variety of features. Now we have all of these nodes here that are interconnected in some complex way that we don't necessarily know what it is. What we basically can control is how many layers are going to be here. And so what we're going to do is just guess how many layers we need, and then one would train these up. And so what will happen is these layers will learn features of the data. Well, what's a feature of the data? Well, it's hard to say exactly what that is. We might talk about features in the sense that humans can understand. So we might say, like, we want to understand how to recognize this object here, which is a purple pen. And so to a human, the attributes might be its shape being cylindrical, and it might be that it's the color purple. And so then it would also be maybe compared to other objects. So here I have a paperweight holder here. And so it's a different color and also a different shape. But we would also want to be able to differentiate purple pens from maybe you have blue pens. And so then the color would be something. So we might say from a human perspective, there might be an attribute called color and then another attribute called shape. Now, when machines are doing the learning, they are not necessarily extracting the features in the same way that humans would do it, but actually that doesn't really matter. That's the beauty of artificial intelligence. It is going to extrapolate whatever works. And so basically by having data that has known yeses and known nos, that kind of thing, having that labeled data, it's going to give it the ability to select between the two by optimizing how the hidden layers are working. So many different attributes may be learned, and we'll take a look at some sample data on how this is working. And so it will pull out those features. And so what that means is that each of these nodes then will then have some feature associated with it that is going to then score the input on. And during the training phase, that feature will be becoming refined. So it will learn, like, okay, maybe, you know, sharp straight line of pixels is a good thing to recognize a pen. And another one might have some other aspect of it. And it might realize, like, oh, if we recognize the object from head on, also looking like a circle might be also acceptable. And so there could be multiple paths through the neural network that would allow it to get a good score. And so it's also learning the connectivity between them. So these arrows here are also becoming learned. And so then it comes down over here through all your hidden layers over to your output layer, which then will tell the results to the user. And that's essentially how neural networks are functioning. So suppose we had a set of images where each image contains one of 4 different categories of object. And we want to do the deep learning to automatically recognize which object is in each image. So what we can do is we can label the images in order to have the training data for the network. So this is where we're putting those tags on. So here's the input image. And so then what we're going to do is we're going to walk through these things to try to identify which of these 4 items it is: a flower, a cup, a car, or a tree. And so there are going to be a series of processing that's going to happen. And so these are the filters. So this idea is that it's moving through the neural network and it's pulling out some certain features of it. So applying those filters is what's causing the features to happen. So what is that filter? Well, it could be some kind of a mathematical formula that it's doing or some kind of operation. Here it's operating on the input image. And so you see that if we apply a certain kind of a filter, we could get out a general shape. Like this kind of a shape is going to be a flower. And this kind of a shape may also be recognizable from a different filter, and that also helps it to recognize like these are the edges of the flower, and which will help it to say like this plus this is going to then be a flower. Now these things are much more abstract, so like I was saying, some of the things may be not human interpretable, but could be important for the machine learning because of the way that it separates out those features. So each layer in the network is going to take the data from the previous layer and it's going to transform it, and then it will pass it on to the next one. The network is going to increase the complexity and detail of what it's learning from layer to layer, and that's how the sorting is going to happen. So the network learns directly from the data. We don't have any control over which features are being learned because they may not be human recognizable features. So what exactly is this? So deep learning is a subtype of machine learning. Why is deep learning different than regular machine learning? Well, it has to do with the number of layers. So with machine learning, you're going to extract relevant features of an image, but with deep learning, you're going to feed the raw image directly into a deep neural network that's going to learn the features automatically. So here we have a depiction of traditional machine learning. So there would be some kind of manual feature extraction. So say, for example, you were going to use a Markov state model. To some extent, you are going to tell it, this is the number of categories there are, like these are the features to look at. And so then the classification would occur on that basis. But in deep learning, we don't specify what happens in here. That's happening automatically inside the machine. So machine learning tends to have good results with small data sets, whereas deep learning requires very large data sets. Well, oftentimes this is because it typically is going to have many more parameters. The more parameters you have, the more data you need to train it, and because you don't want to be subject to overfitting. Machine learning tends to be quick to train a model. However, for deep learning, this is much more computationally intensive. We need to try different features and classifiers to achieve the best results because we don't necessarily know which ones are going to be the most useful. Whereas in deep learning, the features and classifiers are learned automatically. The accuracy of machine learning will plateau at some level, but the accuracy for deep learning is unlimited. So today what we're going to do is we're going to go ahead and actually get started with a machine learning task. So we're going to use census data from California, and we will try to predict the value of housing based on the number of rooms in the house. So as you might expect, we could have a hypothesis that the more rooms are in the house, the more expensive the house will be. And we would need to have some labeled data on that. So we select this because the state of California has an awful lot of data available, which is very useful for us, and we can download this data. So it's basically an end-to-end project using TensorFlow so that we don't have to get bogged down in the task of actually downloading and installing TensorFlow, which in and of itself can be a little bit tricky and time-consuming. I thought that it would be a better use of our time to just actually do some analysis with TensorFlow. And for those of you who are interested in following up on it more, you can go ahead and download and install it on your laptop. But you can use it online, and you can use the Jupyter Notebooks, which I will tell you a little bit about briefly, just for those of you who may not be familiar with that. So the objective will be to learn the fundamentals of the TensorFlow concepts. We're going to use the linear regressor class and the TensorFlow program to predict median house price and the granularity of city blocks based on one input feature. We're going to evaluate the accuracy of the model's predictions using root mean square error, or RMSE. and we'll improve the accuracy of the model by tuning its hyperparameters. So this is the process of today's lab. We're going to load the libraries, then we would load the data set. Then what we will do is we'll take a moment to examine the data. This is the idea of get some data and become familiar with it, figure out what kind of hypotheses you might have, what you might want to do with it. We'll need to then select a model. So we're going to select the neural networks in TensorFlow. Then we would tweak the hyperparameters, and then we would test the model and iterate through that in order to improve the model. And what the lab will take you through today is doing some of that process. For building the model, this is going to have several steps. We need to define the features, which is the input. That doesn't mean that we're telling it which features, but again, we are providing the data for the model to figure out what it is. Define the target, so that's figuring out what you want to predict. Next, we'll configure the linear regressor, which is what we're going to use as our model today. Then we will define an input function, then we will train the model, and then we will evaluate the model. So in order to set up and run today's lab, there would be some options. As I've been mentioning, we can download and install the required software. So if you're going to run it on your laptop, which you can definitely do, this is what you need to do in order to get things up and running. So as you can see, there are a lot of things that you need to install on your laptop, but if you are going to be doing machine learning, it's something you probably want to do. So you should have Python version 3.5 or 3.6. I will mention that 3.7 is not yet fully supported. I ran into a lot of problems when I tried to use that. So I would actually recommend working with version 3.6. So on my laptop, I maintain multiple versions of Python, but I use 3.6 for this TensorFlow lab and working with TensorFlow because it's not working. The latest version of Python is now 3.8. I haven't tested 3.8, but I'm not hopeful that it will be any more successful than 3.7 was. So that's my recommendation for you, to use version 3.6. If you don't have it and you want to get it, you can go to python.org and download and install it. You'll need to just go to the software page and specify which version you want to get. Obviously, you need to pick the one for the kind of laptop that you have. So I know some of you have been learning some of these other Python tools. So we have Pandas and NumPy. So Pandas is for panel data analysis. It's basically working with large databases. So that's actually part of TensorFlow and is one of the dependencies. So you'll need to have that. NumPy is for numerical Python, which has a lot of the mathematical operations, such as working with matrices and so forth, which is incredibly useful. Also, IPython is some background software that you will need to have. Matplotlib is used for doing the graphing. So we actually had a workshop on this earlier. Some of you may have attended that. The scikit-learn is essentially an earlier version of TensorFlow that was not quite as integrated, but it does have an awful lot of the training algorithms and so forth in it. So scikit-learn is also a foundation for the TensorFlow. And then finally, you need to install the TensorFlow itself. So if you're up for the challenge, that's what you need to do in order to get this working on your own computer. Otherwise, you can choose to use the Jupyter Notebooks, which is online. And in order to get started with this, all you need to do is follow the link we're going to provide you, and you can go ahead and get started. So that is another option. The bad thing about it is that if you decide you do want to do more work with TensorFlow, the notebooks are definitely not the fastest way to work with TensorFlow, but it is a way you can do it. So those of you who are going to be doing it using the Jupyter Notebooks, I thought it might be helpful to just give an overview of what Jupyter Notebooks are like and how to work with them. So I will show you what that's like. So Jupyter Notebooks is basically an online interface that allows you to work with many different programming languages. It's an open source web application. You can create and share documents that contain live code, equations, visualizations, and narrative text. So the great thing about it is you can actually have some code right in here, and then you can actually execute the code. And when you post it, then the users can actually go in and change that. And so you'll be experiencing that today. So you'll be asked to start with some Jupyter Notebook with some standard code in it, and then you will be invited to play with that code and to interact with it and then run it to see what will happen differently. The uses of Jupyter Notebooks include using it as a learning environment like we'll do today, data cleaning and transformation. It's a great way to document the things that you're doing. Numerical simulation, statistical modeling, data visualization, and machine learning are all things you could do with it. So it has interactive output, so you can code in a variety of languages, and then the output will come out in ways that you can look at, so like HTML, images, videos, latex, and custom MIME types are a few of the ones that are available. You can also share your notebooks. Notebooks can be shared with others using email, Dropbox, GitHub, which is a large online repository for coders, and also the Jupyter Notebook viewer. We can also integrate this Jupyter Notebook with big data. So we can use many other tools besides just TensorFlow on here. We can use Apache Spark, we can use Python, R, Scala, scikit-learn, ggplot2, and TensorFlow are just a few of the ways that you can use the Jupyter Notebooks. So learning how to use it for TensorFlow is really great, but what we're suggesting here is that you can integrate this with other kinds of programming that you want to do. And then if your particular project involves different kinds of programming that are linked together, like perhaps you're going to have TensorFlow for part of it, and then maybe you're going to take the output of that and you're going to do something else with it, run it through maybe your own lab software or whatever. You can integrate all of those things in this one place, which is useful. There's also a wide variety of supported programming languages here. So it supports over 40 languages. Some of the more popular ones are Python, R, Julia, and Scala. So it does offer a considerable amount of flexibility. So I thought I'd just show you how to use the Jupyter Notebook and see what it would look like. So here is an example of a very simple Jupyter Notebook. So this is a single page that only has a bunch of executable code in it. So this is going to compute seconds in a day. And so this is just a simple multiplication, right? And so what this is going to do is it's Python code. And this is a variable that's equal to the multiplication of these numbers. It'll report the numbers of seconds in a day. And just like any Python interpreter, when you type the variable name, the value of that will pop back up. So that's what's happening here. The result is being shown down here. So what you would do in order to interact with this is you would select the box by clicking on it, and then you could edit the code. So maybe you wanted to change this up, and then you would press the play button, which is this right here, which would then update this number down here. And so then you can have multiple of these windows linked together in the same document, maybe even have some text in between or something to explain, you know, what's happening. And so that's basically how you would use the Jupyter Notebook. So it's actually pretty easy to get started to be a user of the Jupyter Notebooks. So it is what I would recommend you would do to get started. So today's exercise is right here in this link. There's also a brief guide sheet, which basically just reiterates many of the things I've just said and also provides you with this link. So what you should do is you should follow this link and go to this TensorFlow exercise, which then is going to take you through that project end to end about the data on the California housing. So with that, then I would encourage you to go ahead and try out the lab. I will be happy to help you through that and answer any questions that you might have about that. All right, well, thank you very much. I hope you enjoyed my introduction on TensorFlow and found that helpful. And I look forward to seeing you next time. Bye-bye.